Hi class, welcome to another math video. Tonight's video is on lesson 1.8 from the textbook, solving equations using algebra tiles. This small square yellow tile was called a unit tile, and one yellow tile represents positive 1. How many unit tiles are below? We've got the 5 yellow positive tiles, which means it would be positive 5, and we call this the constant in the equation. This yellow tile is a variable tile. It's longer, it differentiates itself from the unit tile. How many variable tiles are below? We have got 2 variable tiles. We call this the variable in the equation, therefore this would be 2x or 2n, whatever we decide the letter to be as the variable. What algebraic expression do the tiles below represent? 2 variable tiles, 5 unit tiles gives us an expression of 2x plus 5. Another one, what algebraic expression do the tiles below represent? Here we have 6 unit tiles, we have 4 variable tiles, therefore the answer could be 6 plus 4x. Again, in an expression that involves addition, it doesn't matter the order that we have them in, so 4x plus 6 would also be acceptable. How would we use tiles to represent 5x plus 3? Using our cutouts, we have 5 variable tiles. The 3 yellow unit tiles would give us 5x plus 3. Using tiles, how would we represent 6x? In this case, there's no constant, so all you would have is 6 variable tiles. There is no constant, so we do not use unit tiles. True story, Mr. Hughes collects Star Wars action figures. I gave him 2 more. He now has a total of 7. How many Star Wars action figures did he start with? Mr. Hughes is indeed a cool dude. If we let x be the number of figures, write an algebraic equation to represent the question. So now equation indicates that there is an equal sign. So we look for clues in the question. And the clue that jumps out for me, he now has a total of 7. That would mean that 7 would come after the equal sign. If I gave him 2 more, he's adding to his collection. So, with that knowledge, x plus 2 equals 7 is our equation. We can all probably figure that out. 5 plus 2 equals 7, but we're going to investigate a little bit further. We can solve this equation using algebra tiles. We draw a vertical line down the center of our page to represent the equal sign, and again from top to bottom, that's likely only about 2 lines long on your page. We arrange tiles on each side of the line to represent the expression or number on each side of the equal sign. So therefore, on the left-hand side, we put tiles that represent x plus 2. We have our 1 variable tile and our 2 unit tiles for x plus 2. On the right-hand side, we put tiles that represent 7. So in this case, 7 yellow tiles. We want to solve this equation, we need to get the long x tile on its own. So if we treat this equal sign like a balanced scale, whatever we do on one side of the scale, we must do with the other to keep it balanced. To get that long x tile by itself, the textbook often refers to it as isolating the variable, or getting it all on its own. When we solve an equation, we must preserve the equality, which means whatever we do on one side of the equal sign, we must do to the other. To isolate the x tile, we need to remove 2 unit tiles from the left-hand side. To preserve the equality, we must remove 2 unit tiles from the right-hand side. The tiles show that the solution is x equals 5. The textbook will often say verify the solution. So in that case, we take our answer, x equals 5. We put 5 in the place of the x for the original question. It becomes 5 plus 2 does equal 7. We know we got the answer right, therefore the solution is correct. If we are asked to draw this in pictures, we would write out the original x plus 2 equals 7. We would show that we are getting rid of 2 tiles from both sides, and then underneath it we would draw what the answer is. X equals 5. Another true story. Mr. Meldrum tried to do some math at 11:18 p.m. the other night. He spent 10 minutes making an answer key to the Big Five. He then spent 4 minutes per quiz marking. He spent a total of 26 minutes before passing out of exhaustion. How many quizzes did he mark? If we let x be the number of quizzes, write an equation to represent the question. So again, we look for clues. The first clue that jumps out at me, he spent a total of 26 minutes. So whatever our answer will be, it'll be equals 26. If I spent 4 minutes per quiz marking, that indicates that I'm doing some multiplication. And 10 minutes making an answer key, that's our constant. So therefore, 4x plus 10 equals 26. Now, we can excuse me, we can likely solve this through inspection, and if we figure out that 4 times what number, when we add 10 to it, equals 26, okay, a lot of us can do some mental math and figure out that 4 times 4 equals 16, plus 10 does equal 26. But we'll investigate further with algebra tiles. We draw a vertical line down the center of our page to represent the equal sign. We have to, on the left-hand side, we represent 4x plus 10. So 4 long variable tiles, 10 small unit tiles. We do the same on the right. We put 26 unit tiles on the right-hand side. And the first step to get one x tile all on its own, which we call isolating the variable, the first step that we need to do is we must take away 10 from the left-hand side. We first remove 10 tiles from the left-hand side, so we draw the picture like that, getting 10 away. To preserve the equality, we must remove 10 unit tiles from the right-hand side as well. Our equation to this point now reads 4x equals 16. What that's asking is 4 times what number equals 16? Doing some mental math, we'll know that the answer equals 4. So there are 4 x tiles remaining on the left-hand side. If we were to arrange the unit tiles remaining into 4 equal groups, this is what we could do. There is 1 x tile for every 4 unit tiles, so therefore the answer is x equals 4. If the textbook asked you to verify the solution, we would take our answer of 4, put it in the place of x, and see if we did get 26. 4 times 4 is 16, plus the 10 is 26, so therefore we've gotten it correct. Textbook also suggests that if to verify it, we replace each variable tile with 4, that was our answer, to see if we are equal on both sides. Our homework, guys, was lesson 1.8, and I asked you to do practice numbers 1, 2, 4, 5, 6, 7, and 8, and this was due Friday. Good luck, everyone.